This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and I'm pleased to be talking to Max Welling today, researcher and founder of CuspAI. Max, it's an honor to have you with us. Welcome.
Thank you very much. It's nice to be here, Robert.
We met at NeurIPS. Do you remember you grabbed the manna waffle and then you were off to the next lecture? Nice that you have now time for us.
Yes, it was a very nice cookie, I think, that I grabbed.
Yeah, manna. It's very popular in Germany and Austria. Yeah,
Brilliant.
So, Max, what is life like an entrepreneur?
It's very exciting, I would say. As a startup entrepreneur, of course, running a startup is somewhat of a roller coaster. There's ups and downs all the time, and one day is a high and another day is a low. But what is beautiful about running a startup is that you're at in the driving seat.
Mm-hmm.
And so you and, of course, a small team, like in this case, CuspAI is about 20 people, can move quickly, change course quickly, and do what we think is relevant and important.
How difficult was the change for you coming from academia and now to be an entrepreneur?
Not so difficult, I would say. Of course, I've served 2 times in industry. I first was in Qualcomm, which was 4 years, and then also at Microsoft. So I had industrial experience. Before that, I actually had another startup, but I was less involved in that startup than I am with this startup. But, it's of course a different skill set where I would say the biggest change relative to academia is in academia, you're sort of more working yourself on problems. It's more something individual effort. Where definitely in a startup, you work in a team and it's all about teamwork. And I think realizing that and building an excellent team and a good atmosphere, good culture in a company is, I think, extremely important. And of course, you also need good culture and a good team in sort of academia, but you work mostly one-on-one with your students.
We are the Industrial AI podcast, and that's why we want to talk about your company. How did you come up with the name? I'm interested in the name CuspAI. Why CuspAI?
Well, there's 2 reasons for it. Well, we think we're at the cusp of if you wish, a water shift, or we call it a sea change. And that's because AI for science is gaining momentum and AI is being used in the natural sciences, and in particular chemistry and biology and physics. And that's sort of like a paradigm shift, actually. And then the other thing is that a cusp is actually a technical term in chemistry, in quantum chemistry, which is basically something that changes very, very quickly, let's say.
What do you get $30 million for? Please explain us a bit. What is CuspAI doing?
Right. So we build a platform to design materials. So we have sort of 2 established sort of application areas. One is gas separation, and prominent there is carbon capture technology. And the other one is semiconductor materials.
So that's your Qualcomm history, right?
Yes, or definitely relevant here, yes.
Mm-hmm.
But I would say, as we are reaching sort of smaller and smaller chip sizes, we are designing chips at the nanometer scale. Quantum effects will become important, and silicon is cheap and abundant, but it might not be good enough for the next generation of chips. And so now people are talking about designing the chip and the material jointly, and we want to be part of that change.
Let's talk about technology. What do you work with? Do you build large models? And if so, how? How can we imagine that? Do you use deep learning approaches? Can you go a little bit deeper?
Right. So the platform we build you can think of it as a search engine for materials. It's built as a machine learning or an AI tool, but with a lot of chemistry inside. So the team that we have hired is also mixed. So we have software engineers and machine learning researchers and chemists and material scientists. So there's the different machine learning models that we are training are generative models where you generate molecules with particular properties that you condition on. We built models for force fields. So these are basically machine learning models that, given a structure, will give you all the energy of the structure as well as all the forces on every individual atom so that you can solve it in time and do simulations with them. We are building property predictors, which are models that try to avoid the simulation altogether and predict the properties directly. And we're building an agent, which is basically a search agent.
Everybody's building an agent today, right?
You have to building an agent. That's right. 2025 is the year of the agent.
Yes. Yes.
And so we also are training an agent, but
so you need to do that for your VC capital, or you want to do something with the agents?
So in fact, we already in a very early we said that we were training an agent.
Okay.
So this is a reasoning agent that orchestrates the computation. So it's basically a search agent. It needs to understand, where to allocate computational resources for what particular task. It will figure out, what materials to generate and how to generate them and how to evaluate them.
So, and which data do you use when it comes to your research platform?
So most data is in databases like Materials Project and Nomad. There's a Cambridge Crystal database. So there's a whole bunch of these publicly available databases. At the same time, we work with companies, and companies tend to have data. And we also generate in-house data that we do through simulations in the platform.
Synthetic, or what is it?
Yeah, hypothetical structures, basically.
Okay.
To use these quantum chemical code like DFT to label these structures with their properties.
Okay. Who are your customers? You mentioned your customers. You always explained us it's semiconductors, and we want to go in this field. But can you share a little bit some industries you want to focus with that?
Yeah, so we can talk about actual companies that we work with. Yeah, so it's companies that do carbon capture. We have contacts with those. We have currently a very nice project with 2 partners, which is called Skyvolt. In Skyvolt, we basically have a 6-month timeline to design a material and then actually synthesize it with one partner, and then characterize the material, and then actually put the material in a rig, in a carbon capture rig, to actually test it. And so we search for metal organic frameworks, which are specific class of porous molecules or materials that is very good at capturing the carbon dioxide.
Mm-hmm. Which models do you use when it comes to this Gen AI approach? Is it built by your own, or can you share a little bit more?
So we do work extensively with Meta. So basically, some of the models that they feature on their website, is for instance, MACE is a force field, or Equiformer, or these models. These are equivariant sort of deep neural networks that we would typically either train from scratch or fine-tune for our purposes. Yeah, and in terms of generative models, we would, at this point, we have an autoregressive model over latent code that generates, and then actually there's a piece of software that then actually instantiates the molecule, and then the molecule needs to be relaxed to its ground state.
If you look at the market, what is your unique selling point when you talk to your customers?
So the first thing is that most companies in this space don't have excellent machine learning teams. They see it's very important, but it's very hard for them to even understand how important it is for them.
Because it's faster, more efficient. Can you drop some? What do you mean with why is it so important in this field?
Well, it's definitely, the simulation can be accelerated a lot. Or if you need DFT inside your, let's say, MD, molecular dynamics loop, you're going to be very slow. And so these days, you can put machine learning force fields to replace these DFT calculations. So that can accelerate it orders of magnitude. Of course, all of that needs to be implemented on GPUs and all that. And so we are working on that as well. Yeah, so I think if you ask me relative to sort of other companies in the sort of more machine learning space.
What about MetaGen, for example, the model by Microsoft? Is it a similar approach?
So MetaGen is a generative model for sort of small crystalline structures. So a MOF is a much larger structure, so that's definitely could be hundreds to thousands of atoms. At this point, we don't do diffusion models, but this for the future. We have a sort of an approach where we have a sort of latent code that sort of encodes all the possible structures, or very large, like over 100 trillion structures. It's called PoreMake. And then we have basically a generative model over that code.
Mm-hmm. Okay. You mentioned domain knowledge. You have people from BASF, for example. How do you bring AI, machine learning, and domain knowledge together? How difficult is that, or how easy is that for you?
Well, I think it's, crucial in a way. So we have, of course, chemists inside the company, but, if you engage with the company on a particular problem, so they typically have simulators and domain knowledge of the problem and data. And we have kind of the platform that will then connect to that data knowledge to then basically search for molecules that they also characterize. So they say, we want molecules that can do this, this, and this. And here's a simulator that can tell you whether it's doing well or not. It's just too slow for them typically. And so we can help them train better force fields. We can help them design materials much faster.
Mm-hmm. Can you explain a little bit your business model? Your platform is not yet online, or will it never be online? Or how do you make money out of it now?
Yeah, so at this point, we are in a very early stage of the company, so we're not making money. We are building the platform. So the business model is going to be that we will actually internally use the platform to search for molecules, and then we patent them.
So you need to type something in like a Google search.
Well, yes, but it's of course much more iterative and practical, right? So
Sure.
you work with a chemist and you inspect the things that come out. If a company wants to design a molecule, you want to do as much work as you can in a computer because it's much faster, and therefore you want to have as few experiments as possible, and the structures that you sort of evaluate experimentally need to be very high probability of success.
Mm-hmm. And does the user work together with the machine learning model, or does the model work in the background? And so everything is focused on the user and the magic is happening in the back.
No, it's definitely you interact with the platform. So there's a whole bunch of tasks in the platform that can do things automatically or semi-automatically. But so you call for a DFT calculation, or you call for a learning algorithm that trains a network or fine-tunes a network or distills a network, or you name it. So you need to know what you're talking about. So you need some machine learning knowledge, I guess. It's not completely fully automated. So it's not a platform that's customer facing.
Okay, but it's not your goal, right? It should be like you explained it, right? You don't want to have let's call it big word, AutoML approach or something like this.
No, at this point, that's not what we want, because that means you would spend a lot of effort on making the interface very user-friendly, and you need to have support teams if something goes wrong with the software and people have questions and all that. So that's a very serious decision. So at this point, we just build a platform for internal use, or use, if we're working with another company. But basically, we can sort of help them, also operate.
But they can build a product on your platform, right?
No, that's not
on top.
No, we do it together. So and at this point, the platform is in development, maybe half a year old or something. So at this point, we do design molecules, but we do it completely in-house.
Mm-hmm. Okay. Let's talk at the end a little bit about Europe and the USA. Yesterday, there was this big announcement by the European Commission, or the European Commission, to spend, I think, 50-60 million euros in an own large language model. What is your opinion on that?
I think it's good. Now, 50 million is, of course, nothing.
It's not much. Yeah.
No. I mean, I think a single training run
exactly
these days for these big models are, you're talking billions already. Or, well, okay, that depends on where you are. I mean, clearly DeepSeek sort of disrupted that idea a little bit, so that we can now train these models much more cheaply. I think it's very important that Europe gets into the business of doing this stuff itself, sort of gain experience, build an ecosystem around this, create, curated data for this, do it in a way that's acceptable for European standards and ethics. All of these things are, I think, very important. It's just that, this is just some European grant, and, that's not, nearly enough to be serious.
Mm-hmm. You are not in the Gen AI fever at all. What will be the next thing from your point of view?
Well, I should say I'm very impressed by the developments, right? And we build our own sort of Gen AI models, but I tend to not spend my time in places where there's a million other people already working, because I don't think I can contribute very much. So I'm working, so this is not with CuspAI. I mean, CuspAI, we built this platform. So in my academic job, we're currently looking at completely different ways to train models or to design new architectures based on oscillatory networks. And so that.
Can you go a little bit deeper? What does it mean?
Yeah. So the idea is that instead of having a neuron that is in a particular state, it could be a real number, it could be a vector or something, but it's always in a static state. We tend to think of neurons as sort of oscillating entities, and neurons try to synchronize with each other. So in neuroscience, that is known as binding, which means that if you have certain neurons that code for one thing and neurons that code for another thing.
Binding was a big topic at Google DeepMind, right? Or am I wrong?
I don't know about that, but really a big topic in neuroscience.
Yeah.
So if two neurons bind together, they sort of start to express that they're talking about a bigger object which has sort of these properties which are bound. And so we've already built models, some of our students like Cindy Lowe and Andy Keller, they have built models that are based on this kind of wave-like dynamics, which by the way is also observed in the brain. Waves are seen more and more often in sort of when people study the brain with multi-electrodes. And sort of this idea of synchronizing neurons as they go deeper in the network is called competitive learning. This is also a very old concept, and you build more abstract representations. But we are finding that models which are sort of inspired by physics, of course, physics is, there's a lot of waves going on in physics. Like think about, of course, electromagnetism, but you can also think of quantum field theory. All of these are based on waves. And we find that these waves have very beautiful properties. They can aggregate information over long distances and over longer periods of time. So they have sort of memory properties, and they can be surprisingly well trained. So the other thing is they can reason, because this is like an optimization algorithm that's similar to spin glasses, but then with kind of oscillations. And so you can train them to solve Sudoku puzzles. We also find they're much better calibrated for uncertainty, and they have a high level of robustness towards adversarial attacks.
Oh, okay, that's interesting. I want to come back to CuspAI at the end. What is the next goal in the company?
Right. So the next goal in the company is to deliver within a period of 6 months, to deliver a material that is actually designed and synthesized and tested, and then see if that material operates in the real world, right? So we want to go through the whole pipeline of not just doing things in a computer, but actually then saying how realistic is this particular material if you start to synthesize it and if you start to test it in an actual carbon capture machine. From that journey, we will learn a lot. And so, we will perfect that particular, workflow so that we can also apply it to other materials like semiconductors, for instance.
What kind of people are you looking for?
In our company, currently, we sort of stopped hiring a little bit for a while because the team is now consolidated and we're now in sort of a building mode. But the people is the very best machine learning researchers.
Where do you hire them? It's in the US or is it in Europe?
It doesn't matter. If they're willing to come to our offices, which is Cambridge, Amsterdam, Berlin, Edinburgh, and Lausanne, if they're willing to be in one of these places, we don't care where they come from. But mostly at this point, I guess European researchers, because, we have very, very good researchers in this field in Europe. Somewhat unique. And of course, Europe is a lot cheaper still than the US in terms of salary. And so we believe this is a very good place to build these companies.
Mark, thank you for your time. I keep my fingers crossed for you and for your research and for your company. All the best and greetings to Amsterdam.
All right. Thank you very much, Robert.